All right. Okay, so we will be going over 4.2 and 4.5 today. So if you remember, I know it's been like 2 weeks since we've met. It's been a while. But 4.1, we introduced what polynomial functions were, and we learned about some of their properties, which included the multiplicity of their zeros. We talked about that. And we talked about the leading term behavior, or the leading term test to analyze the end behavior of the graph, what's happening at the ends. So that's what we did in 4.1. We learned a couple of other things, but those would be the two most important. And we also learned how to find the zeros of them by factoring, setting them equal to 0, and then solving for x. So we're going to use all of that knowledge now in 4.2 to actually graph them. We are going to learn a couple more properties. And I'm going to give you some tricks to get through this homework really quickly, okay? It really shouldn't take you that long if you just know 3 things. It should be really quick. Okay, but first, and a few of your questions are going to be based on this first property here that we're going to learn. So this first property says that if p of x is a polynomial function of degree n, so remember degree means the highest exponent of the polynomial, so n will be the highest exponent, then the graph of the function has at most n real zeros. And real zeros are the x-intercepts. So at most x-intercepts. So if the degree is 3, that polynomial will have at most 3 x-intercepts. It can have 3 or less. It will not have more. And then the next one says that that polynomial will have at most n minus 1 turning points. Turning points are the points that occur at our local minimum and local max. So it's the points where it changes from increasing to decreasing or decreasing to increasing. That's why they're called turning points, because they change from increasing to decreasing or decreasing to increasing. So on this picture down here, an example of the turning points of this graph would be this point down here at the bottom of that valley or that dip, and then this point here, which is at the top of that hill. Those are my 2 turning points of that function. And that is also, like we learned, the local min and the local max of that function. So they're the same. So that's what this point here says about the turning points. And so that is always 1 less than the degree, is at most how many turning points a polynomial function can have. So for example, in this picture that I just kind of introduced, the function of that graph is given by the equation f of x equals negative x cubed minus 2x squared plus x. So the degree of that polynomial is equal to 3. And so there, 'cause that's the highest exponent. So therefore, this function has at most 3 x-intercepts or zeros. Same thing. X-intercepts are the same thing as zeros. You're going to see on your homework that it's going to say this function can have at most blank zeros, number of zeros. And then it's going to say this function can have at most blank number of x-intercepts. They'll be the same answer every time because they're the same thing, okay? And then this function will have at most 3 minus 1, which is 2, turning points. So we already talked about the turning points. Those are the points in blue. And we have 2 of them, so that checks out. And if you zoom into this, well, you can't zoom in, but if you look at yours, this function has 1, 2, 3 x-intercepts. So that also checks out with the at most how many x-intercepts this function can have. Okay? So nothing too crazy there. So like I said, a lot of your problems on your homework will just be asking you about that. So you just look at the highest exponent and then answer the question. Any questions about that? Okay. All right. All right, so like I said, in this chapter, or section 4.2, a lot of it is just graphing these polynomial functions. And a lot of your homework and your exam will just be, they'll give you a function and then you'll have multiple choice to choose from. So it's really just going to be about process of elimination. There's only 2 of them on your homework that you do by hand. And I'm going to show you how to do those by hand as well. But most of them, it's just multiple choice, pictures of graphs. And I'm going to tell you the easiest way to eliminate them. It should just be super quick by just looking at the leading term. Okay? And the zeros, plus you. But here are 6 steps or techniques that we use to graph polynomial functions. They don't necessarily have to be done in this order, but it's just 6 things that you can refer to in order to graph it, especially if you're doing it by hand. So the first one says to use the leading term test to determine the end behavior. That's very helpful, okay? It seems like it might not be that helpful, but this is going to honestly help you answer like 50% of those questions just by doing this, because you'll be able to eliminate all of the other ones that don't have that end behavior. The next one is to find the zeros of the function by setting the function equal to 0 and then solving for x. And then, of course, those will give you your x-intercepts. So that's another really important one because you can easily, well, hopefully by this point, you can easily find the x-intercepts and then eliminate any graphs that don't have those x-intercepts. The third one is really just important if you're doing it by hand or if the multiple choice graphs get, like they give you a bunch that are really similar, then you might need to go a little further and use number 3. But and I'm going to explain what this means when we do an example. But this says to use the x-intercepts to divide the x-axis into intervals and then choose test points, so like x values that are between those intercepts, to determine the sign of the function values in that interval, or more specifically, it just really shows you an actual point in that interval that you can specifically graph. Okay, but we're going to talk about that. So you'll definitely need to be able to do that when you're graphing the ones by hand. But most of the other ones, you won't even need to do number 3. Number 4 is to find f of 0, which means to plug 0 in for x. And this finds our y-intercept of the function. Remember, to find a y-intercept, you plug 0 in for x. So that's another point you can use to do your process of elimination, to look on the y-axis and find the y-intercept, just in case they give you ones that are very similar. Number 5, if necessary, find additional function values. So remember, you can always plug any value in for x and find a point, and then compare it with other points on the graph that they give you, okay? Okay, number 6, as a partial check, you can use the facts that we just learned about how many x-intercepts and how many turning points it should have, or at most how many it should have. But the important one of number 6 is the multiplicity of the zeros. This is very important, or very useful, I should say. So remember, I said I'm going to tell you the 3 most useful ones to use to do this process of elimination. These are the 3. Use the leading term test to determine the end behavior. That test alone, if you understand that test, it's gonna eliminate and give you the answer to like 50% of these problems. You won't even have to go any further. But if they do give you multiple options that have the same end behavior, then the next thing you would want to do is find the zeros of the function. And then that will eliminate and give you most of the other answers. And then after you find the intercepts, the next thing you should do is determine the multiplicity of those intercepts. Are they crossing or bouncing? Because that's what we learned that multiplicity teaches us. And those 3 things will really give you a general shape of your graph. And then if for whatever reason they give you ones that are very, very similar and all 3 of these match, then you'll go on to the other tips, 3, 4, 5, to narrow it down even further. But most of the time, these 3 will answer them. Now, of course, like I said, if you're doing it by hand, you will definitely have to do some of 3, 4, and 5. Honestly, 3 and 5 are kind of saying the same thing, in my opinion. But okay, so let's do some examples. Everybody good? Did anybody not get a handout? There should have been 2. I see that we ran out of any. Did anybody not get both of them? 4.2 and 4.5? Which one do you need?
I have 4.2, but I have 4.5.
I think I have something like that. All right, so number 1 says graph the polynomial function f of x equals negative x cubed plus 2x squared. And we're going to do this by hand. But again, like I said, there's only really 2 on Pearson that you need to do by hand. And I'm going to pull up Pearson and show you how to do those. But anyways, so the first thing we're going to do is the leading term test. Now, if you're writing down and copying my notes, you want to write small because we got a lot to write here. So the first thing we're going to do is the leading term test to analyze the end behavior. So what is my leading term? That's my degree. But what's the entire leading term? Negative x cubed, the entire thing with the exponent of 3. And so, yes, the degree is 3, which is odd. And the leading coefficient is -1, right? Because that's negative x cubed. So technically that's -1 in front of x cubed. -1 is negative, obviously. Okay, so when your degree is odd, the highest exponent is odd, your end behavior is going in different directions. One is either going down and one's going up, or vice versa. And if your leading coefficient is negative, then it should be going down from left to right. So the right should be going down. It should be decreasing like this. So my end behavior would be like this. And I'm just drawing it here for now, but we will be using this when I graph it. So that's what's happening at the ends of my graph. Okay, step 2 is to find the zeros, or the x-intercepts. And to do that, I set the entire function equal to 0. So I would have -x cubed plus 2x squared equal to 0. And now I need to solve this equation. How do I solve this? Factor. They have and all of these with polynomial functions, it'll either be already factored for you, or you will have to factor it. But you will be able to factor them. There'll either be a GCF that you can pull out. It'll be a quadratic, so you can use one of our quadratic techniques we've learned to factor. Or it'll be 4 terms, and then you factor by grouping. Okay, so you will always be able to factor these and find their zeros if it's not already factored for you. So what is the GCF here? X squared. And you could use -x squared, it doesn't really matter, but I'll just use +x squared. That will leave me with a -x plus 2. So now I take both of these factors, this factor and this factor, and I set them equal to 0. So x squared equals 0, or -x plus 2 equals 0. And I solve both of these equations. So if x squared is supposed to equal 0, then x has to be what? 0. Because the only number you can multiply to get 0 is 0. If I put any regular number in for x there, it'll be not 0. So this will give me x is equal to 0. That's the solution for the first one. And the next one, I can add x to get the x to be positive over here. And so x would be equal to 2. So these are my 2 x-intercepts. So I can go ahead and plot these on my graph, because those are 2 definite points that will be on this graph. Now, again, I'm doing this by hand on, not paper technically, but you're doing it on paper, on my iPad. But if you were doing it by hand in Pearson, I would suggest that you sketch it on your paper first. And I'm going to explain why. Because you can't just go into Pearson and plot these 2 x-intercepts right away. Like, you can't do what I'm about to do. You can't plot 0 and then plot 2, because it'll think you're trying to do a straight line. Pretty sure. But, so I will show you how to do that. But, yeah, either way, I would highly suggest that you sketch this on paper first. It's going to help you so much than just trying to do it right away in Pearson. It's best to get a general shape first, like we're doing here with these problems. All right. Now, the next thing I'm going to do, like I told you, is I'm going to analyze the multiplicity of these zeros. So I'm skipping all the other 3, 4, and 5 right now. Because, like I said, these 3 are the most important and will give you the general shape right away. So, what I'm going to do for step 3 is analyze the multiplicity. And I'll just write multiplicity. I'll follow through. What is the multiplicity of the 0, 0? Which is this 0 here, our x-intercept, I could say. That's the first 0 we found, or x-intercept. And to figure out its multiplicity, I look at the exponent of the factor where that 0 came from, which it came from this x squared, right? That's where that 0 came from. So that exponent on that factor is 2. So the multiplicity is 2. So again, if you weren't here last week and you haven't watched, well, I just posted the video because I'm terrible. But if you haven't read the textbook or anything, then I posted the video for 4.1, so make sure you go back and watch that so that you can understand what's happening here. But what the multiplicity tells us, if it's even, which this one is, do we remember what happens when it's even?
It goes above.
What'd you say?
Do an up shape? I don't know.
You're okay. It either means it crosses or bounces.
Oh, that's
It
right.
bounces. Bounces. So it goes to that x-intercept, touches it, and then goes back the way it came from. Okay, and then the multiplicity of 2, of the 0, 2. So I'm talking about this 0 we found here would be 1. Because that is the exponent of the factor of that 0. Technically, there's nothing written there, so it would just be 1. And this multiplicity is odd, so the graph will cross at that x-intercept. Okay. So, I'm going to draw the basic shape of this graph using what we've done so far, but if you might want to wait until I do the step after that, because I'm probably going to erase stuff on the graph. So you might want to wait and don't copy what I'm about to draw. But I'm just going to show you that this will give you the basic shape of the graph, which will help you eliminate a lot of those multiple choice graphs, and you won't have to go any further. So first of all, the end behavior. I'm going to use what we did with the end behavior. I found the 2 x-intercepts of this function. There is no more x-intercepts, okay? The graph will not touch or cross anywhere else besides what I've just plotted. So if my end behavior Running out of colors. Let's use orange. My end behavior here on the left is pointing up. Then I know for a fact that from the x-intercept all the way to the left, this is pointing up. I already know that. Now again, don't draw that yet, because I'm going to fix it. And then the other one that's going down is going to come from the x-intercept all the way to the right. And that's just going to go down. That's always true. You just, the x-intercept's all the way to the left, it'll just start doing what we said the end behavior does. And the one on the right will start doing what we said the end behavior does on the right. Now, to figure out what's happening in between, I use my multiplicity. So the zero of 0, the x-intercept 0 right here, we said will bounce. So it goes and it touches just like it already is, and then it's going to go back up. It's not going to cross. And it's going to go up some amount, but it has to come back down eventually because it has to go through that x-intercept. Has to. I don't know how high it's going up right now, or, you know, how low, whatever. That was just a rough estimate. But it has to go up some and then come back down. And then the x-intercept of 2, which is right here, it has to cross, like we said. So it's crossing. So that right there is the general shape of the graph, which you can use to eliminate a lot of your, again, it's not a great drawing, but that will give you the general shape, and you'll be able to eliminate most of the problems, the multiple choice, and answer the questions. All right, now, if, let's say they give you a couple of options that have the same shape, and you need to go further, then the next thing you could do is find some additional points. And remember on that list of steps over here, number 3, it says you can divide the, use the x-intercepts to divide the x-axis in intervals and choose your test points. So what does that mean? It means that from all the way from negative infinity to, negative infinity to this first 0, that's one interval that I can just plug in. I can pick an x value there, say -3 or -2 or -1, any of those, and get a point in that interval. And then the next interval would be from 0 to 2, between those two x-intercepts. So I could plug in like 1 and get a point for that interval to get a more definite shape. And then the last interval is from the last x-intercept 2 to positive infinity. So I could plug in a value there and get another point for a more definite shape. That's what that means. So that's what we're going to do. We're going to find additional points. In the intervals created by the x-intercepts. Now, again, even when you do this by hand on Pearson, you won't have to do them in all of the intervals. I'm going to show you, but I'm still going to do it here just to show you how to do that. All right, so let's start with the first interval on the left. I'm going to choose -1 because it's always best on the left and the right to choose the x value closest to the 0. Because if not, you're going to get a really high number and you won't be able to even graph it. So I'm going to plug in -1 to the original function. So that would be negative and then negative 1 cubed plus 2 times negative 1 squared. Negative 1 cubed here is going to be negative 1. Negative 1 times negative 1 times negative 1 is negative 1. But then I have another negative on the outside. So that'd be positive 1. And then negative 1 squared is positive 1. And positive 1 times 2 is positive 2. So that'd be plus 2. And so this would equal 3. So this just gave me the point. I plugged in negative 1 for x, and then I got 3 for y. So that's a definite point on my graph that I can plot. So see, it's not quite lining up over here. So I'm going to erase it now and actually plot that point, negative 1, positive 3. And so I know it's doing something like that, more specifically. Now I'm going to choose a number in the second interval. So I'm going to choose 1 since it's right in the middle. So I'm going to plug in positive 1. And that will give me negative positive 1 cubed plus 2 times 1 squared. 1 cubed is just 1, and then I have the negative, so that would be negative 1. 1 squared is 1. 1 times 2 is 2. So that would be negative 1 plus 2, which is just positive 1. So that just gave me the point 1, comma 1. So I plugged in 1 for x, and I got 1 as my output. So now I can erase this little thing I did here and actually do it more accurately and plot that 1, comma 1. And so it should look something like that more accurately. And then finally, I'm going to plug in 3 because that is a number on the interval all the way to the right after that x-intercept. And that will give me negative 3 cubed plus 2 times 3 squared. 3 cubed is 27. And so that would be negative 27 because of the negative on the outside. 3 squared is 9, and 9 times 2 is 18. And so, I can't do math in my head today. Is that 9? Negative 9? Negative 9. So that gave me the point 3, comma, negative 9. Okay, so negative 9 goes off my graph, but that's okay. I'm still going to erase this. So that'd be 3, negative 9. It would be like way down there. So I know that it's not crossing 3 until it gets down there. So it's more like something like this. I don't even really have to plot that point. I'm still going to do that for my end behavior. Okay? So again, these are the most important techniques you can use to graph these things. What is my y-intercept? 0. So I wouldn't even have to find the y-intercept because it already was one of my x-intercepts. So 0, 0, the origin is an x-intercept and a y-intercept. Also, you know, obviously we've seen that these polynomial functions can have more than one x-intercept, but they will never have more than one y-intercept. They'll only have one. Because they're functions, so it can't repeat y values. Or x values, sorry. So it'll only have one y-intercept. Any questions so far? Okay, let's do another one. Okay. What? It's not that bad. At least it's already factored for us. It's not as bad as you think. All right, so number 2 is the graph, or the function x minus 3 all squared times x plus 1 to the 4th power. So again, first thing we're going to do is analyze the end behavior using the leading term test. Now remember, if you were here last time, that if it was already factored like it is here, I kind of gave you like a technique to find the leading term, because you definitely would not want to FOIL this all out and multiply it all out. That would take you forever. We don't have time for that. So what you need to do is figure out the leading term of each factor first, and then multiply those together to get the leading term of the entire polynomial. So if I look at the first factor here, if I did FOIL that out, what would my leading term be? X squared. Because you would just have x times x. X squared. And also, let's say you had no idea that that was true by looking at it. Well, just take the x and add the exponent of 2 to it. That's going to be the leading term of that. X squared times, so what would the next one be using that technique? X to the 4th. So now if I multiply those together, I really just add those two exponents, and that would be x to the 6th, right? So the leading term, if I multiplied all of this out, would be x to the 6th power. And there's no numbers in front of x. If there was, like say there was a, I don't know, a 3 here in front of that x, well then there would be a 3 here in my leading term, because that would be multiplied in there. But there isn't, so I don't need that. Okay, so my degree would be 6. That would be the largest exponent of this polynomial if I multiplied them all out. And then the leading coefficient is just positive 1. Leading coefficient of this leading term is just 1. So the degree is even, which means my end behavior is doing the same thing. They're either both going up or they're both going down at the ends. And because it's positive, the leading coefficient is positive, they would both be pointing up. They're happy, they're positive, they're smiling, they're even. So my end behavior looks like this at the ends. Okay, step 2, we're going to find the x-intercepts, or the zeros.
Can I ask you something real quick?
Yep.
You said the leading coefficient is positive, even though it's 1?
Mm-hmm.
Oh, it's not negative, never mind.
Yeah.
I'm thinking about odd or even.
You're okay. So we're going to find the x-intercepts, which are the same thing as the zeros. And we do that by setting the entire function equal to 0, and then solving for x. So just by looking at this, what would my zeros be? 3 and negative 1. Perfect. So remember, when you solve an equation by factoring, and this is already factored, so it's already factored, I really just set each factor equal to 0 and find out what makes those factors 0. Well, the exponents don't even really matter. What matters is what makes the inside 0, because 0 squared is still 0. 0 to the 4th power is still 0. So I only care about what is making the inside 0. And that would be 3 and negative 1. So my zeros are 3 and negative 1. Yep, just flip the signs. Because if you plugged in 3 in the left one, 3 minus 3 is 0. And if I plugged in negative 1 into the second one, negative 1 plus 1 is 0. So I can go ahead and plot these points, these x-intercepts on my graph. So positive 3 would be right here. Negative 1 would be right here. Step 3 is to analyze the multiplicity. My step 3. I'm going out of order based on the list I gave you, but this would be the steps that I would go in. And I'm telling you to go in. So the multiplicity of the 0, 3 would be what? 2. Perfect. So again, that comes from the exponent on the factor of that 0. That's where I'm getting that from. And so this is even. So will my graph cross or bounce? Bounce. I always remembered that. Now again, you can put all this on your flashcard if you want, if you can fit it on there. But I always remembered that, which is so weird. But sometimes the weirdest ways we try to remember things is what helps. But I would always think of a pogo stick. You guys know what a pogo stick is? So you need 2 feet on a pogo stick, so an even number of feet to bounce. That's how I always remembered that. And then odd crosses, so they both have like O's. Bounce has O, but odd cross, I don't know. Sounds similar to me. Okay, and then the multiplicity of the 0, negative 1 is 4. Perfect. Because that's the exponent on that. And so that's also even, so that will also bounce. Okay, and then sorry. So I'll go ahead and draw a rough sketch of this graph using what we've done so far. So again, my end behavior, the left side will be pointing up. So I know from this very left x-intercept, it'll be pointing up. And again, this is just a rough sketch. I'm going to find a couple additional points to make it more accurate. And then on the right side of the last x-intercept, I know that that one will be coming from there and pointing up as well. Okay, so that's based on my end behavior. And then based on my multiplicity, these both bounce. So I know that at the 0 of -1, it comes down, touches it like it already is, has to go back up because it bounces. And then it goes up some amount, I don't know how much, but it has to come back down to touch that other x-intercept. And then like we said, that one also bounces, touches it and then goes back up. So it looks something like this. This is a general shape of your graph. And now we can find some additional points. So I have 3 intervals that I would want to check here if you wanted to be super accurate. This interval on the left of the first x-intercept, the interval in between the 2 x-intercepts, and then the interval to the right. 3 intervals I could check and plot specific points. We're going to find some additional points. Okay, so the first, now again, you can pick any x value in the interval you want, but I just always like to pick, especially on the left and the right, I like to pick the x value closest to the intercept. So I'm going to pick f of -2 first and figure out what's happening at x value of -2. And when I plug that in, I get -2 minus 3 all squared times -2 plus 1 to the 4th power. -2 minus 3 is -5. So that becomes -5 squared. -2 plus 1 is -1. So that becomes -1 to the 4th power. -5 squared is 25, and -4 to the 4th power is a +1, because any negative to an even exponent is positive.
So this is
This is for, I'm finding another point to the left of -1. So I plugged in -2. And I just found that at -2, my graph is going all the way up to 25 for y. So I'm just finding another point in to the left of that intercept. So I obviously can't graph 25. This gave me the point -2, 25. But I do know what that tells me more specifically, if I was just doing this by hand, is that it's not even crossing -2 until it gets way up there to 25. So I can just make it more narrow. But again, you're going to see when I show you how to do this on Pearson what's actually important, okay? All right. Then I'm going to find a point in between my 2 zeros, in between -1 and 3. So I could plug in 1. I could even plug in 0, really. It doesn't matter. And that would be 1, 2, 3, 4, 1, 2. But the reason why I'm going to plug in 1 is because it's in the middle of those two. And so that should give me my local max point there. So I can really see how high that hill is going up. So if I plug in 1, I would get 1 minus 3 all squared times 1 plus 1 to the 4th power. 1 minus 3 is negative 2, sorry, squared, and 1 plus 1 is 2, so it'd be 2 to the 4th. Okay, negative 2 squared is a positive 4, and 2 to the 4th power is 16, and 4 times 16 is 64. So this is a huge number, which means, so that gave me the point 1 comma 64. I plugged in 1, I got an output of 64. So 1 comma 64 would be way up there off my graph. So that means it's going up, 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 and I'm just going to pretend like this is 64 up here. It's a pretty weird drawing. And then, of course, you could find another point in this interval. Choose 4 for x. And figure out what that gives you. I'm going to skip that one because I think hopefully we get the point. Okay. What I want to do, I'm also going to skip number 3, but only because I'm about to do one on Pearson. That's almost exactly like this. So I'm going to actually show you how to do this on Pearson by hand. We good so far? Not opening? I'll check on it.
Is it possible to check your work with the TA before?
Yes.
Okay.
Yep.
But we still have to work it out by hand. Or could we just do it on the TA before and use the table to find the points that we need?
The pop-up is probably blocked.
I mean, you could, yeah.
Okay.
But you still need to know the properties of how to do it by hand, because like on your exam, it'll ask you like,
So I don't know.
what's the end behavior of the, well, I guess you could use your calculator for that too, but, yeah, yeah. Let me come back to your question. I'm surprised this is following me. Usually it doesn't follow me on my iPad. You talking about quiz 7?
No, ma'am, the pop-up blockade is blocking me from
Okay. What does that say? Okay, I'm going to 4.2 homework. We're going to do this example. I'm going to do it on the board. So if you're listening in the video, I will post the notes on how I did it on the board on the notes, so you can go back and refer to those. All right. So again, we're going to do this very similar to what we've been doing up until this point. Pretty much same thing, except at the very end. It's just a little bit different. So the first thing I'm going to do is determine my end behavior of this graph. by using the leading term test. And the leading term of that function there is x cubed. So the degree is 3, right? Which is odd. And the leading coefficient is a positive 1, because that's what number is being multiplied by the x cubed. So this is positive. So my end behavior when the degree is odd, they're doing different things. One's going down, one's going up. And when it's positive, it would be going like this because it should be going up to the positive direction, increasing to the right. So the left will be going down and the right will be going up. Okay? Step 2, we're going to find the zeros or the x-intercepts. So I would take that whole thing, x cubed plus 4x squared minus x minus 4, and set it equal to 0. And how would I solve this? By grouping, factor by grouping. Because there's 4 terms, that's how I know that. So I factor the first 2 and I factor the second 2 terms. So the GCF of x cubed and 4x squared would be x squared. And that would leave me with x plus 4. And then what do I pull out of the second group? Negative 1. Because, yeah, it starts with negative. We always have to pull something out. So even if they don't have a common factor, you pull out positive 1. But because it starts with a negative, we need to pull out the negative. So that would be negative 1. And if I factor out a negative 1, it changes the signs of these two. So that would just be positive x plus 4, which is what I want so that these match when you factor by grouping. Okay, good so far? And then finally, to finish factoring this, I write down the one that matches. And then it gets multiplied by what's left on the outside, which is x squared minus 1. And then from here, I set each of these equal to 0. So this one should have been pretty easy to see. It would have been negative 4, right? Or I would subtract 4 to both sides, but negative 4, that's my first 0. The other one, this can be solved 2 ways. You could add 1 over and use the square root property, or you can factor it because it's a difference of 2 squares. I'm going to factor it because it's important to know this. It factors to x plus 1 times x minus 1. Right? So my answers would be negative 1 and positive 1. Which is the same thing I would get if I added 1 over, took the square root of 1, I would get plus or minus negative 1. Or, sorry, plus or minus 1. Because the square root of 1 is 1. Good? Okay, so I have 3 zeros. So let's talk about the multiplicity of them. What would be the multiplicity of negative 4? 1.
Sorry, I was looking all the way at the top.
Because you would look at the factored. You want to look at the factored version to identify the multiplicity. And then the factored version, this is 1. So the multiplicity is 1 here. Now, you have to be careful with stuff like this because let's say you didn't know that this factored, which you should. The multiplicity of this is still 1. So if you would have taken this and set it equal to 0 like this and added 1 over blah, 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 you might get mixed up and think the multiplicity is 2, but it's not. It's 1 because of this and also because of this. Both of these would have a multiplicity of 1 because it can still be factored further. Okay? And the difference between this x squared being on the inside and that other example that we've seen where we had x squared on the outside, blah, 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 this gave us the 0, x equals 0. Well, this was by itself, so the exponent of that factor is 2. So the multiplicity of that was 2. But here, the x squared's on the inside, so the multiplicity would just be 1. Okay? So all of these have a multiplicity of 1. All right, so now I'm going to sketch my graph. Oh yeah, it fell. On the board, or you would do this on your paper before you try and do it in Pearson. You want to sketch it by hand first. So my zeros are -4, 1, 2, 3, 4, -1, and +1. So here's my 3 zeros. I know my end behavior over there. So at the very leftmost 0, it will be coming from the 0 and going down. And then the very rightmost 0, it'll be coming from that x-intercept and going up because of my end behavior analysis. Okay? And then all of these multiplicities are odd. So they'll all cross. All of them. They're all 1, so they're all odd, so they will all cross. So this one has to go up and cross through here, then it has to come down at some point, cross through here, then it has to go back up at some point and cross through there. Cool? Cool. Okay, so this is a general shape of my graph. So, see if I can do this. Okay, so you're going to, when you graph this, once you get the general shape, you should know that it has some, squiggly stuff happening in the middle, so you would want to pick this squiggly line option. Right? And then we will start with plotting the first x-intercept to the left, -4. Okay, so there's that. I want to see something real quick if it does work. Oh, it does work. Okay. I wasn't sure, so I guess you could plot your all your x-intercepts first. I thought you had to go in order. But I guess you can. So if I plot -4 here, -1 and 1, those are my 3 intercepts. And now I need to find an additional point so it can get the right shape. Okay? So what I would suggest to you I guess it doesn't really matter.
How'd you do that?
I just plotted one more point.
Oh,
I picked, it was a random one, not the right one.
oh.
So, okay, so I'm just testing stuff right now, sorry. -4, -1, and 1. Okay, so there's my 3 intercepts. Oh, no. Sorry. I accidentally hit the button. -4, -1, 1. Okay. Now, because this one has 3 intercepts, I really only need one more point. If it only had 2, you might need to find 2 more points. But I just need one more when it has 3. And you'll find that out. Once this tool that we picked, the squiggly line tool, you only need 4 points to graph it, and then it'll know the rest of its shape. It's kind of cool like that with the technology. So you can pick any point, any interval, really. So what's an x value you want to pick? 0. Great choice. And if we pick 0, what would it be?
0.
No.
Oh. You guess. You guess.
If I plugged in 0 to this, what would I get? -4. Because everything else would cancel, right? This would be 0, this would be 0, this would be 0, and it would just leave me with -4. And what is this called? Huh?
Constant.
Y-intercept.
Y-intercept. -4 is a constant. It wasn't really a wrong answer, but this is a y-intercept because we plugged 0 in for x. So x would be 0, so this would be -4 right here on the y-axis. So now I'll just plot that point, 0, -4 to 4, 2, 4, 6, 8. Okay, that was right. And see, everything else it just did for me. And that's it. I'm done. Let's check it. Excellent.
Try again.
Okay, so like I said, really these leading term test, multiplicity, and then you just find one additional point. Really, that's all you need to do. Well, if it only has 2 intercepts, you'll probably have to find 2 additional points, but you will have to. All right, and then I'm going to show you a couple of these other ones, and we're going to take a break. Okay, so this is good. So there's only 2 you have to do by hand like we just did. The rest of them are these multiple choice ones. So I'm just going to show you kind of how easy this should be. So this one, what's my leading term? 15x cubed. So my degree is 3. So it is odd, right? So my end behavior should be doing separate things. So that already eliminates B. Can't be B. Because B's end behavior is both going up, yes.
Didn't you say when it's negative, it goes down to the right?
Yes.
So it's A.
But is 15 negative?
Oh, no.
No.
You're right.
Yep, but you were correct, yeah. But what that really does is eliminates A, right? Yep. So it's odd, so it's doing different things. So we eliminate B. 15, the leading coefficient, is positive, so it needs to be going up to the right. So now that eliminates A. So we're either at C or D. Okay? Now, to narrow it down further, you could find the x-intercepts, or you could find the y-intercept, because I already see that the y-intercepts are different. The C has a y-intercept of what? 0. And D, I mean, I don't know right now because it goes all the way up to 250. But let's see if it's 0. If I plug in 0 for x, what would I get? 24. Because every other term would cancel. So what's the answer? D. Because it's not going to be 0, 0. It has to be 24, which is a little, would it be higher than 0? So I didn't even really have to write anything down to answer that, as long as you understand what y-intercepts are and you know the tests. But yeah, some of these, like this one, the leading term is x to the 4th. So my degree is 4, it's even. And it's positive 1 is the leading coefficient. So that narrows it down to which two? E or D. These two. Because even degree means they are going in the same direction at the ends. Positive coefficient means that they're both going up. So it's either E or D. That's what matches that description. And then what would my y-intercept be? -9, the constant at the end. Because you just plug 0 in for x. So let's see if that helps me narrow it down. Yep, that one's -4, so it's not that one. That one's -9. So therefore it's E. So a lot of these really shouldn't take you that long. That's one I already did by hand. A lot of these really shouldn't take you that long. This one eliminated all, this one just the leading term test gave me the answer. Because the degree was odd and the coefficient was positive, so that's only A. So, as long as you understand these tests, it really shouldn't take you that long. Okay, I'm going to stop there for right now, and we're going to take a break.